This is, we've added a bunch of stuff to the, just for the Amatrol. I hadn't got the information for the Festo line, but we'll play around with Amatrol. So the Amatrol consists of 7 stations, or modules. They refer to modules. And if you look at the front, they're numbered. Module 1, 2, 3, 4, 5. And this is all the information that comes. Well, let's pick one. So normally they give us a module overview, then a module picture, and then of course the components that make up this module. Okay. By the way, the way Festo numbers their diagrams, it all depends on how it's laid. Not Festo, I'm sorry. Amatrol, which deals with Siemens, by the way. So Siemens and Amatrol has worked in conjunction with this line right here. So all the information we're seeing is not from Amatrol; it's actually from Siemens. What happened? So when they lay out the diagram, especially the pneumatics. So this line has a lot of pneumatics on it, and so does the Festo line. But so y'all logged in the backboard, y'all looking at this with me? We're looking at the pick and place feeding, which is this is the pneumatic diagram, and we'll explain this to you. So these are symbols for what we call directional control valves. And these are called 2 position valves for obvious reasons, because you can see the 2 positions, right? 2 positions. And what happens is that this is a symbol for a solenoid. Y'all know what a solenoid is? What is it? A solenoid is a device that converts the power source into a linear motion. And these are electrical solenoids. Did I show you my solenoid?
Oh yeah, oh, where's my nail?
Hello guys. Nail. They were very impressed up at Siemens bottle when we were talking about solenoid. And I showed them my little solenoid made out of a drinking straw. I'll see if I can find something metal to suck up in there. And what you have to visualize in your head is you have to visualize this block shifting. So what would happen right now, if pressure would come through, and it would come through this, see the arrow? It would go up through this flow control valve. And then it would come over here and push on this side, which would cause the cylinder to retract. If I shift this whole thing over with that solenoid, then now the pressure is going to flow up through here, right? You understand, through port 4. So this will go to port 4, this will go to port 3, and it would route the pressure on this side of the piston and cause it to do what? Extend. By the way, these are what we call check valves. These are flow control valves. This is using a technique called meter out, which we're not going to concern. So what would happen is it would come over here, and it would bypass this. See the little check valve right there? So you can vision that little circle as a ball, and if it pushes it out, it'll push it out of that cradle, and then it'll go through and push this. But when it vents, on the other side, when it's pushing air out, the check valve would close, so it would go through this flow control valve, and what we're doing is we're controlling the speed. So we have 2 things in a fluid power system that we're concerned with. We're not only concerned with the pressure, we're concerned with the flow. So what does the pressure determine? The amount of force. So force is basically equal to area, well, how much we're pushing against times the pressure. What does the flow rate determine? The speed. So if we adjust the flow rate, we're not going to change the force. We're going to change the speed that the fluid flows, which would change the speed of the actuator. So these are, what's an actuator? Have we talked about that in this class? It's the device that converts pressure into motion. And we have rotary actuators and linear actuators. Are we okay? Now, the way Amatrol or Siemens likes to number things is they look at an actuator. So that's actuator. And it's the first one on the left. And then this right here would be some type of actuator. This is the function. This is the vacuum generator. And then this would be, so 1, 2, 3, 4. So what they do when they have a circuit or an actuator, the first letter would be what circuit that belongs to. So this would be circuit 1. This would be what? 2. This would be 3. And this right here would be 4. Okay. And if it's got a V, it means it's a what? Valve. If it's got a B, it means it's some type of actuator. I'm sorry, 1A. A B, 1B1 and 1B2, so B is for sensors.
B is
Sensors. So the actuators are pretty obvious because they're 1A, so that would be the actuator. So that means this guy right here has 2 sensors on it. We have a sensor that senses when it's fully extended, and that would be what? 1B2, okay? And then we have a sensor that determines when it's fully retracted, that would be what? 1B1. That makes sense? So Siemens labels their sensors with B's. A's are what? Actuators. B's are what? Valves. Right. M, I think, is a solenoid. Yeah, it is. Now 0, this is what we call a service unit down here. So this is what services the thing. So they're labeling this 0 because this is not controlling an actuator. It's controlling the whole system. This is a symbol for a filter. So when you look at these things, it's that glass bowl that's down in the bottom. So what happens is the air comes in, has to flow down through that and back up. So any impurities inside the air or anything that's heavy would fall into the bottom, and that's where the water would be released.
You said the O is a surface.
In pneumatics, we call it a service unit. A service unit consists of more than one unit. So we have a pressure control valve, which is right here, and it has a filter. So if the filter was by itself, and then we had a pressure control valve by itself, we would call it a filter, and we would call it a pressure control valve. But we take those two and put it in one unit, we call that a service unit. So a service unit, a pneumatic service unit, consists of more than one device, right? You understand? So if I had a lubricator inside of this, then that would be part of a service unit. If I had a lubricator outside of this, then it would be a lubricator. So the lubricator has a symbol. Now normally when we see these dashed lines right here, what does that mean? That means it's all enclosed in one unit. And you can see these real easy over there. And of course, what's this a symbol for? It's a symbol for a meter. But if it's connected to the service unit, of course, it's going to be a pressure gauge. And this right here is, by the way, this would have how many ports? 4. So the number of ports on a valve, we call it the number of ways. So this would be a 4-way valve. But that's not the way it goes. And it's kind of strange. What we do is we start off with the positions. So how many positions can I put this valve in? Yeah. So we'd say 2, 4, and then we say I'm sorry, we say 4/2 valve. So they start off with the ways,
4 ports.
4 ports,
4 ways.
then they say the number of position, and then they say ways. So this actually goes with that. So it's kind of strange why they do that, I don't know. So we'd call this guy right here a 4/2 valve. So this would be a 4/2 valve, this would be a 4/2 valve, this would be a 4/2 valve, this would be a what? This would be a 3/2 valve. Manually operated, by the way. So this guy here is manually operated. So this is our disconnect for our air. So a lot of people don't understand when you're working or actually doing physical work inside a unit and you want to remove power, we're talking about all power sources. So that not only means your electrical power, it also means your what? Your hydraulic power or your pneumatic power. We have 3 power sources. We have what?
Electrical,
Hydraulic, and pneumatic. So that's our disconnect for our air. And it's got a lockout on it. It's got a little notch, so when we push it in, we can put a lock on it. So this right here would be the second actuator. So what this guy right here does is it converts a what? A pressure into a vacuum. We got both lines have this on there. So instead of having a vacuum pump and a pressure pump, we have devices that takes what? Pressures and converts them into vacuums. Usually it's what we call a ventura, which they'll come up here and blow the pressure through a real narrow opening, and then it'll spread back out, and then we tap it right there. So if you got a pressure washer, it works exactly the same way. So your pressure washer has this little valve you can hook up to it, and even though it's generating pressure, when that air flows through that ventura, it creates a low pressure side, right? And then what does it do? Then it'll suck like soap or whatever you want in your pressure washer. It'll automatically suck it in the stream. So you don't have a pump on your pressure washer pushing that soap down in there. It's actually the flow through that ventura that's causing a low pressure side that does what? Creates a vacuum, and if it creates a vacuum or a low pressure, then it's going to pull that stuff down through there. So we use that to generate the vacuum. I can show you this on the Festo, and we'll show you it on the. So we got 2 suction cups on both. We got suction cups on both these lines. We have a unit that takes a pressure and converts it into a what? A vacuum. And we have sensors, 2B2, 2B1. So the B means it's a what? No, B, excuse me, as Baker, is a sensor. B is a valve. A's are what? Actuators. And what we do is they number it according to when they're encountered on the line.
What we say M
Core.
M is a solenoid.
That's like the position where we pushing when you push like man.
Not the solenoid. What you can do is normally it has some buttons on top. Just about all, I'm going to say, most devices in industry has the ability to do what we call force. Okay, your relays you can force, and most of your actuators you can force. I'm sorry, your valves. You can't force the actuators, but you can force the valves that control that.
So you said they are sensors, but isn't that really the electrical connection that we run from there?
No, this is the name of the sensor. They don't show the electrical connection at all.
Okay.
This says, okay, I have a 1B1, which is a sensor that indicates when the cylinder is fully retracted. And of course, these are reed switches, right? And then 1B2 would be for the fully extend. When I go over here, so we got 2B2, which is probably a sensor that senses pressure, right? We need to look at this symbol. I don't know what these symbols are. And we got a 2B1 over here. It's also sensing something to do with that vacuum. Over here we have a sensor 3B1, which senses if it's fully retracted, and 3B2, which fully extend. Now every manufacturer has their own technique. This is what Siemens uses, but it's very similar to what you'd find in Festo and stuff like that. So we okay? So this is not the electrical, so it don't show the connection. So it don't show the connection to this solenoid. What this is the pneumatic. But now when we start looking at these charts and we see 1B1, 1B2, and all this kind of stuff, we'll know that B's are what? Sensors. V's are valves. M's are solenoids. Okay. So this will make sense when we go over here and look at these other diagrams. So we'll come over here and look at what we call the step diagram. Well, what they're saying, okay, this is everything we can do. We can extend cylinder 1A. We can turn the vacuum what? On or off. Cylinder 3A, we're going to either extend it or retract it. And then the linear transfer cylinder, we can either do what? Extend or retract. So what they're saying is we follow this on. So the first thing that's going to happen is what? Cylinder A is going to do what? It's going to track. How does it know it's retracted? Right there. What does it say what sensor we're looking at? Yeah, it says we're looking at 1B1. I'm sorry, 1B2. Okay, before it extends it, that's a good idea. So before it extends it, it looks at what? 1B1. And then it goes up here, and when it's extended, it sees what? 1B2. And what happens then? We follow this line right here, down to here, and what's going to happen? So this is the start. This is the startup condition. So 1B1 indicates this is what? Retracted. Okay, this is start right here. This is before this thing will run. This is the start condition right there. So what it does is it looks to see that 1A is what? Retracted. How does it know that? By 1B1. Okay, it looks to see that the vacuum's off. How does it know the vacuum is off? It looks at 2P2, right?
2P1.
2P1. We need to look at that. Then how does it know that that cylinder 3A is retracted? 3B1. And then cylinder 4A is retracted, so it looks at 4B1. So that's the condition it looks at before it goes to the first step. If this is true, then what happens? It'll extend it. Okay, and then it'll drop down here, and if 1B2 is true, then what's going to happen?
Still looking at 3B1.
It's going to, this guy here is going to go to 3, right? You understand? This guy here is going to do what? It's going to stay extended. Okay, y'all understand what we're doing? This guy right here, this whole time right now, is going to be what? Retracted. Ain't this neat? This is what we call a step. They call this a step diagram. And what it does is it gives you the step in the whole process. So there's 11 steps in this process. And then when it gets through the 11th step, it does what? Yeah. So we look at this, and this, and this, and this. What do we notice? It's exactly the same as the start condition. So here we go. So this guy right here is looking for 1B2. So when this guy extends to 1B2, then we'll move to this one. Then what's going to happen? This guy here is going to do what? It's going to turn the vacuum on. So the vacuum comes on step 4, right? This guy stays here. This comes over here. So we're at step 4 right now. So as soon as 2P1 makes, then we're going to move to step 5. So where does step 5 take us? This guy here will retract. Yeah, this guy right here will do what? No, it's already extended. No, right here. So we're right here between step 4 and 5. So this guy right here, we're moving to step 5. So you're right, it's going to stay what? Extended. This guy right here is going to do what? Stay retracted. Now what triggers the next step? Well, we're looking for what? 1B1. So when 1B1 makes, what are we going to do? We're moving to step 6. What's going to happen? This guy here is going to do what? It's going to stay retracted. This guy right here is going to do what? Yeah, retracting. And what's going to happen here? This guy right here is going to do what?
Stay retracted.
Right here. We're right here at step 6.
Stay retracted.
Yeah, right here at step 6 it's retracted. It's going to move between step 6 and what? Step 7. Now these guys are hard to develop, but man, if you got them, you can see this. We know right off the bat that this guy's got 11 steps. And we can follow this thing on each step, so now we know what to anticipate when this thing moves. Right? You'll understand. So between step 6 and 7, what's going to happen? So what does 1B1 trigger? So here we're looking for 1B1. This guy here is going to stay what? Retracted. This guy right here, which I lost, is going to do what? Stay on. Vacuum's going to stay on, right? You understand. What's going to happen to 3A? 3A is going to stay retracted, but what happens to 4? Yeah, it extends. So we're not saying start. So what we're doing is we're jumping from 6 to 7. Okay, now we're looking at what? 4B2, which is, we could go over and look at the diagram and see what 4B2 is. So now we're going from 7 to 8. So what's going to happen to cylinder 1A? It's going to stay retracted. What's going to say the vacuum is going to do what? Stay on. What's going to happen to cylinder 3A? It's going to extend. What's going to happen to cylinder 4A? They extend. And we've got what they call, this is what Siemens calls their step chart, which is really, really neat. So what we're showing is we're showing what sensor is actually triggering this step. So if I come over here and this guy right here does not change, then we're going to probably look at what? 3D2. Of course, it would have shown up before those. Y'all understand? So this is what Siemens refers to as their what?
11 step.
Their step chart. Everybody okay with that? By the way, from what I understand, this is the kind of stuff that they test on on the Siemens certification, on the mechatronics certification. So I can see Vision, this class is probably doing the level 1. We can do the level 1 in this class right here. Of course, we're still learning, so let's go back. What's next? The next thing we looked at pneumatics, the flow diagram. So this is kind of hard to see for me. We didn't cover these in class, but that's one of them that's available. We did cover the function chart, and this is another method of showing you steps. So over here we've got the same thing. Before it starts, 4B1 has to be true, and what Siemens uses this up arrow to indicate what we call an AND. So it means this has to be true, this has to be true, and you have to press the start button. So 4B1 has to be true, B1 has to be true, and the start button has to be pressed. And if all this is true, then we can do what? Yeah. And this, by the way, this is a category. He wasn't really clear on what that was. But what Siemens does is they call their output ports on their PLCs, they label them Q. So this would be Q. This would be in the 4th group. And then it would be the 5th output. Yeah. And we got by the way, we got a little better chart, which is really, really neat. Because what it does, and I'll show you that in a minute. And then if this is all true, it's going to do what? It's going to actuate actuator 1A, and then it's going to look for what? 1B2. And then it does what? Falls into that, right? You understand? So if 1B2 is true, then it'll come down here, and then it's going to activate what?
Output 4.6.
Yeah, 4.6, which is going to cause what? 3A, and then it's going to look for what? 3B2. So this is what we call, what Siemens calls a flow, their flow chart.
Which,
Or I'm sorry, their function chart.
where you had Q is the output, 4 is the...
Oh, we left this out right here. So what this is looking for, let's drop down here. So 1B2 is true. So if 1B2 is true, and then how does it know 1B2 is true? Well, it's going to, this is 1B2 is connected to N, right? Group 1, number 3. So we could actually look at the, so this is showing us what it's looking, so if this is true, it falls down in here, so y'all understand? So this means, okay, it's going to look for what? Now what they're doing this is the step number. And then this right here is the actual module number. So we're dealing with module 1, step 1. This is module 1, step 2, right? So if this guy here was to go out and look at another module, then what we would know, of course this guy here does not look at any other module, but that's what Siemens does. So if it comes down here, this is going to activate what? Output 4.6, right? Which is going to cause what? 3A to do something. And it don't tell us which direction, extend or retract. So I'm sorry, it does. It says it's right there. And then it's going to activate what when it's extended? 3B2. Now down here, if 3B2 is true, and it's connected to what? Input port 1.5. Y'all see that? Okay, then we'll fall down to this step. This will cause output Q 5.3, which turns on the generator on. And how does it know it's on?
Pressure.
Yeah. So these, I guess, P is for pressure sensors. So it has to be, right? Now this is the one I liked, but so it got to where the instructor, this is true story, would skip over me when he asked questions.
Somebody was bragging on you. Yeah.
And when it came time to do our modules, they had 3 sections. They had the power section, the mechanical section, the PLC section, and we were going to have to do a lecture on one of those sections. And I said, I could do all these but mechanical. And you know what group he put me in? The mechanical section. You know. So when I said I would rather be in a group that does this, he put me in the step chart thing. So, so this is what they call a function chart. And I like this. If you look at it, the step chart is really neat too. Both of them are really, really neat, especially if somebody does them for you. But what we had to do, one of our assignments is we had to develop the step chart for the sorting station. And so what they did is they tried to split the groups up and say, okay, we want y'all to do a function chart and we want y'all to do a step chart. So they put me in the step chart for the sorting station, which was interesting because it doesn't have a lot of sensors on it. It deals with timers, has timers at time. So are you okay here? So this would be a real neat troubleshooting chart if you got a problem. And what you do is you just follow the flow. Did it complete step 1? Did it complete step 2? And it crashed on step 3. then you would automatically know that you would be dealing what? You'd be dealing with 2B1. You'd be looking for what? Input 1, you'd be looking at it. I need to do this up here. You'd be looking at N1.5 on your PLC to see if the light's lit, indicating it's true, right? And then you'd see, okay, does Q5.1 come on, and does the vacuum come on? So if all this is true and the vacuum don't come on, then what does that mean? Well, that means either our vacuum generator is bad, or we've got a broke wire somewhere, or a loose connection. So just because the output of your PLC goes true, it doesn't mean that signal is getting up to the device that it's controlling. I mean, we run all this stuff through wires. Anybody ever run into broke wires while they troubleshoot?
Troubleshooting and making broke wire.
Troubleshooting can make broke wires, yeah. Let's see, who broke our wires off the robot over there when we was...
I'll just follow instructions.
Is that 10.1 still the step and logging on?
What's that?
That 10.1 at start, is that still step and logging on? That on the
Top left, come over, right there.
Yeah, this is coming from the last step. So if we looked all the way down at the very bottom, so the last step they show is 9. So this guy here is going to constantly loop, right? So what that's telling us is that this step is required to start, but it also can come from what? 10.1, which is the at-rest position. So, a good question. Any more?
And the upside down B's are and.
Yeah,
Like
and.
permissive. 4B1.
Yeah, they're it's a permissive circuit, and it's like so if you come up here and see a bar above one of them like this,
Not B1.
it's not B1,
Oh, B1.
or not B1 is what we'd say, which means instead of it being true, it has to be what? False to be false. So this is what they do. So the raise to the power symbol. This indicates what we call a logic what? And. So what you'd say if that bar was up there, you'd say 4B1 and not B1, right? And start. So if it's got a bar above it, it means it's not looking for it to be true. It's looking for it to be false. So we needed to bring that out. So this is a real good troubleshooting guide. So you can actually go over there now, and you can put this thing on step, by the way. So we've been going to auto. But if you flip that sucker to manual, then you are in step mode, which the Festo line doesn't give us the ability to do that. The only way we can step the Festo line is if we hook a computer up to the PLC, and then we tell, and through the Rockwell software, we step. Okay? But the Amatrol line, if you put that thing in manual, it is in step mode, which means you hit the start button, it'll do step 1. You hit the start button, it'll do step 2. And so that's what we'll probably start out doing on the modules that you're assigned to, is let you do what with it first? Just step it and come into like this chart or even the step diagram and actually see these steps occur when there's no problem with it. And what's so neat is these step charts and these function charts are extremely powerful troubleshooting aids. Now the other thing they give us, which is pretty neat, if I can find mine, is this is the PLCs. So this is the actual way the PLC should be connected. Right now, it really doesn't mean much. So here's our input ports. This is a terminal block, by the way. And then so this is yes, but it's got this drain on there. I don't know what they're talking about there. This is the what? Stop button. This is a emergency stop, and this is S2, which would be a switch, right? And then we go from these actual devices to a terminal block. And then from the terminal block, what we have is we have a think it's a 34 pin 1284 connector that runs it down to the PLC. So what we can do is we can disconnect the PLC from the line. The Festo line is really neat in that we have what they call a breakout box, where we can put the breakout box between the PLC and the line, and we can open wires and do stuff that way. And what they had to do on the Amatrol line is they literally took a wire out and put a little piece of tape around it and stuck it in there to indicate a watt, to simulate an open. So if I'd have known it, I took that breakout box up there, and they would probably go, wow. Are we okay? Let's see what we got now. So this is all your I/O assignments. So your start button is assigned, the symbol on the line is S3, and it's connected to what? Input 0.0. Is that pretty good? So this shows you.
Where did you get that from now?
This is called the I/O chart, I think.
Okay, I mean the 0.0 thing. I'm on the chart.
So this is the address. So I means, on the PLC, address means what?
Oh, that's an I.
Input,
Okay.
that's an I.
Okay, input. Okay, I got
Okay.
you. All right.
0, so that's group 0, 0 bit. So Siemens uses what we call the octal numbering systems, which means you notice when I come down the I/O charts, the maximum you'll ever see is what? 7. And then it'll start with 0 and go to 7, which is an octal numbering system. Allen Bradley doesn't use that. Allen Bradley, you know, if you bought a 32-bit input port, then you'd have input 0.32. So it's not designated to the octal numbering system, but Siemens still use that. And the octal numbering system was the name of the game when these PLCs first came out. And what it does, it gives us the ability to represent binary numbers, but we can use it in a base that we understand instead of binary. So what this does is this is the actual PLC assignments, and it shows us the input ports. These are the actuators. I don't know, we'd have to look this up. But these are our what? These are outputs. This guy here might have an analog. This might have analog in it. We need to look at that. I bet you anything these are analog. But we'll go look at the PLC and see if it's got these A inputs on it. The new Allen Bradleys that we got, the 1100s, has 2 analog input ports on them.
Said battery sensor was analog output 8.
Yeah, so PS2 is actually a analog sensor. And what that is, of course, it means somehow we're going to have to set analog to digital, right? Well, when we're dealing with digital, we got 2 ways we can do it. We can have a on-off situation. So most of your sensors are digital sensors, but they're analog sensors. Y'all understand that? But then we run it through a little what we call a comparator circuit, where we can set what is on and what is off. So even though the sensor itself gives an analog value, so your optical sensors give analog values. Your photoelectric sensors give analog values. So that means I've got to through the beam. Well, what if I put something that was translucent through there? Well, we would adjust the sensitivity so it would see that translucent as something there, right? You understand that? So when you look at these sensors, these capacitive sensors, these photoelectric sensors, there's going to be either a knob you adjust, or there's going to be a set screw. Except for one set of sensors I was looking up, you calibrate them. You got buttons on top of it. And you literally put what you want to see in front of it, and you calibrate it. And it'll automatically go up and set the 1 and 0 value. It's really, really neat. I'll have to show you that company, but if you go and look at photoelectric sensors on the internet, I'm sure this company will pop up there. So these guys don't have the little set screws on them or little knobs on them where you set the sensitivity. You can actually calibrate them. And that's all the ones that. Are we okay? Know what the sequence. Let's see what the sequence diagram is. Okay, this is the one I was looking for. So this is telling you the startup condition. So startup condition, I know that input 0.0 would be off, right? Input 0.1 would be what? On. This would be on. 1.3 would be off. So what this does is it gives us those 10 or 11 steps, but what it does is tell us exactly what I would look for in front of the PLC, the ones and zeros. So if it's got a 1, that means that light should be on. If it's got a 0, it means the light should be off. So this was really good. We used this real fast to help us troubleshoot. They put 2 problems in ours. One of them was very obvious when we walked up there. The air was turned off. And they took the pressure, and not only did they have the air turned off, they took the pressure control knob and turned it all the way down to 0. And then what they did to us is they connected a wire to the wrong terminal, which is very, very, very common when people go out and replace things. They try to remember how things hook up, and they don't write it down, and they hook up wires to the wrong place. That happens all the time. Or your hand, or what I like to do, if you got enough cable in your slack in your cables, is put your new one beside the old one and do what? Transfer one wire at a time. That's the way I like to do it. But if you can, if not, you get you a napkin or something, write down, draw the terminals and write down the wire numbers where each one go to. But don't ever try to do that by memory.
Until you have to go to the bathroom, you got to do something.
Well, write them down. You can still write them down. Yeah, that's what usually happens. You know, people. Oh, I can remember that. I can remember that.
Did that, man. Just on 3 wires.
Yeah, 3 wires. I think that's
I remember 3 wires. I did that, man. I can remember 3 wires.
Oh man, I know. I've learned from experience, man, that even with 3 wires, you know, that's a 33% chance of hooking one of them up right, which is not.
3 colors.
If you got 2, you got a 50% chance. But I've seen people with 2 wires hook them up wrong.
What?
Twice. Well, the problem is they hook it up wrong, and they'll say the new part is bad. So they'll go out and get another one, and they'll take this one and they'll hook it up wrong more than once. And I've seen them change out 3 or 4 things before they put 3 things in there before they say, well, something else has got to be wrong besides it. So this is a real neat chart. It shows all the steps, and then what it does. Notice this is the same as what? That. And it's ready to do what? It's ready to cycle back around. So this is a pretty neat chart. Of course, they give us a picture. There's a video too that I haven't uploaded yet. So what Siemens gives us is they give us a video of how that section should operate if it's operating. Unfortunately, the Amatrol line is over there, and all this information would be over here. So if you got a laptop computer or a tablet, you know, that you want to bring in while we're over there, that would be fine. Or you'll end up doing what? Because we can't print these off, by the way. Eventually it will. What they did at the Siemens training is they printed all this stuff off and they put it on the back of a whiteboard. And then what we did on the front, we couldn't look at the back, as we tried to develop these charts just by doing one. Just watching the line and seeing what it did, and look at the steps before it cycles. And like I said, what was really neat about the Amatrol line that we can't do with the Festo line is we can put it in WAS, single step. And you'll hit that button each time, and it'll do one step each time. So let's go over there, guys, and let's look. I'm not gonna carry my computer over there. I guess I should. I could.